And I'm here to talk about PDB. Hopefully by the time we're done with this talk, you'll have a sense of how to use PDB, which is the Python debugger. Before I start, how many people have not used PDB here before? Wow, okay, very good. You shall. So, first of all, what is PDB? PDB is an interactive shell that helps you debug your Python programs. It lets you sort of get a view into your source code and sort of step over your source code as you're developing software. The motivation for this talk is not entirely altruistic. I do a lot of support in IRC and other mailing lists and stuff. And lots of folks will paste a traceback and they'll say, "What's wrong?" I don't know. But you can tell me if you have just a little bit of PDB skills. They go a long way. And if there's anything in Python that you should know how to do, it's how to use PDB, at least just a little bit. You don't have to be an expert in it or anything. So hopefully the goal is to be a little bit more self-sufficient. There are lots of people who say, I don't use a debugger. Usually sort of crusty old types who don't use interactive debuggers. I believe that really everybody should at least know how to use it. It's one thing if you know how to use it and you don't use it. It's another thing to not know how to use it and don't use it. So you should try to know at least a little bit about it. You have some other alternatives. You can write logging statements or print statements out to the console to see what's going on. But often that's just not as efficient as being able to sort of step through your code and play with it interactively. The time that you should really avoid using it is to you shouldn't sort of try to step through the entirety of some complex system using PDB. You should probably just read the code. I mean, it's useful to step through little portions of it, but not the whole thing because it's just kind of a waste of time. So it's mostly just sort of a hit and run thing. So as I talk, I'm going to be using this example, buggy-py, which is a simple 4-line function. It's got one function, a simple 4-line module. It's got one function named divide one by, passed by a single argument, which is the divisor. And we're going to try to divide one by the divisor. And in this Python program, we have a little bit of hair here that says if name equal main, which if you run this as a script will be true. And we're going to call the divide one by function with the value 0. So we're going to end up dividing 1 by 0 over and over and over again during this talk. But that should raise an exception. So there are a few ways to get into PDB mode. Most of these modes, all these modes are actually just ways to get to a PDB prompt. They all wind up at the same place. They're not different sort of operational modes. They all have the same commands and everything. They're just ways to wind up at a PDB prompt so you can start debugging. Three of these things are more important, one of these things are more important than the other three on the list. I'm going to talk about script mode and postmortem mode and run mode. Those things are sort of interesting, but the main mode that I use most of the time is this mode trace mode. So, if you're going to pay attention, shut your brain off for about 3 minutes while I go through the unimportant ones, and then we'll go back. So the first mode is called script mode, and essentially, I don't know if anybody has invoked Python with this -m flag. What Python -m does is it calls the module named pdb.py on your syspath, passing it the rest of the arguments on the command line. So in this case, what this line means is invoke the PDB module using the argument buggy.py, which ends up invoking the script mode. So as we can see in this code example here, if I invoke a Python, pass it -m pdb buggy.py, I'll wind up sort of at this weird paren PDB prompt. And all the modes that we're going to use wind up at this place. This is the point of getting into the PDB debugger. In this case, if we go back and look at the buggy.py script, we'll see that line 1, which is divide one by, is where we end up at, and that's because if you can look at this buggy.py and then in parens 1, that means line 1 of buggy.py. That's because we've started debugging at that line number. So the prompt of PDB is this weird sort of paren thing. Plus, it'll show you a little bit of context about what the file name is and what the file number is. There is an enhanced script mode in Python 3.2+, which is very nice if you're into it. You can pass an additional flag called -c, which will send an additional command to the PDB thing. And one of the nice things that you can do is say Python -m PDB-c continue buggy.py, which does exactly what the last thing did, except it waits until there's an exception to actually put you at a PDB prompt. So the exception gets raised. In this case, we actually trace through the function, and we wind up at the place where we're actually trying to divide 1 by 0, and we can take a look at state once we're there. So this is just a nicety. That -c flag is actually more general than that. It can take a sort of arbitrary number of arguments, or an arbitrary PDB command after it. It's not just that. This other mode is called Postmortem Mode, and what it does is that once your program raises an unhandled exception, meaning that if no exception handler was going to catch it, it's possible to sort of restart your program where the exception happened. Well, not restart your program, but at least get a PDB prompt where exception happened. So in this case, in our example here, we do Python-i buggy.py, which if you've never done it before, Python-i runs a program and then is supposed to leave you off at the greater than prompt, the interactive mode of Python. And at that point, the exception has been raised, and we import PDB and call this PDB PM function, which puts us at the place in our code where we want to start debugging. So this is another useful mode. All that said, oops, damn, got one more mode. There's this other mode where we can sort of import PDB and run an expression under PDB and sort of get to the prompt that way. All of these modes are not, they're fairly interesting, but the main mode that I want to talk about is trace mode. And basically what you do is when you're developing your code, you stick in this one-liner. I actually have this set up in a macro in Emacs. When I hit Alt-T, it types this line out for me. It's import PDB set trace. And what that does is as soon as that line is invoked by normal running of your code, it drops you into the PDB prompt at that point. And it's just another Python expression, so you can actually conditionalize. You could say, if some condition, then drop me into the PDB prompt or whatever. It's pretty flexible. If you use one mode of PDB, this is the one you should use. You shouldn't try to think about the other ones until you've tried it this way. So all that's pretty interesting. Dropping you at a prompt is wonderful, except what do you actually do with the prompt? Well, so the prompt itself is a prompt for a small command language that PDB understands, okay? And the purpose of doing this is so that you can sort of step through your code, print variables, move up and down the stack, get information about the state of your program when it had a problem, or even when it didn't have a problem, you just want to see what's happening in some function somewhere. You can use readline. I'm just going to show you quickly what it looks like to. So I have this program. This is a web program running on a port, and I'm going to hit it with a web browser. And I happen to know that this cloud view function is called when I hit this URL in my web browser. And I've stuck that import PDB set trace function in there. So as soon as this function is invoked, my terminal that I started my web application from will be dropped to the PDB prompt, and we'll see that happen now. So if you'll notice, I'm just going to hit enter on this URL here. It's going to hang. If I did nothing, it would hang forever. And the reason it's hanging forever is because my terminal over here is waiting for me to do something. Okay, this is the PDB prompt. This is the trace mode that I was just talking about. So in this little environment, there are a number of commands which we're going to see, but we can list code. We can print the values of objects, and sort of get interesting information. But one of the nice things about it is that it supports read line, so you can sort of up arrow and down arrow and sort of edit commands on the fly just like you would any other, sort of nominally competent program. One of the other things that you should know about this, some people consider this a miss feature, but the last line, the last command that you enter is repeated when you hit enter. So up above, I've issued the command pp request, which means print the request. And if I hit enter now, it'll do the same thing again. Okay? If I hit N to step to the next line in this function, that's no longer, the pp thing is no longer the last thing I executed. So if I hit enter again, it'll step to the very next line in the function. So. All of these PDB commands have very short, well, most of them have very short aliases. Most of the commands you use all the time are one letter. N is next, S is step, and so forth. Some of them you can't because they start with the same letter, so you have to type the whole command, but the very common ones have a single letter. And another thing, too, is that if you're at a PDB prompt, you can evaluate Python expressions, but when you do that, so if I'm sitting at this PDB prompt right now and I'm sort of in the middle of a program that's suspended, the execution of it is suspended, I can evaluate a Python expression. So if I do 1 divided by 0, it actually raises an exception here. But that exception did not impact the running program that I'm debugging. It's executed in an entirely separate context, so it doesn't, at this point it won't break out of this function because I've issued something that raises an exception. So, while you're at this prompt, type H to see summary of documentation. You can type HP, print the expression, so on and so forth. Pretty simple. The majority of this talk is completely caged from a great article that Doug Hellman wrote about PDB that's at this URL, but if you just Google for Hellman PDB, you'll wind up at it. It's a wonderful resource for learning how to use it in more depth. Now that we're at the prompt, we can actually start to do stuff. One of the things that you want to know is how do I actually figure out where I am in my program, both line-wise and sort of stack-wise. So if you go to your prompt and you type L, you will see a listing of code, and this is sort of context sensitive. I'm going to go back to an editor window that I have open so that you can see what I'm actually debugging, the function that I'm debugging, and we'll see that these line numbers are going to match up with the ones in that buffer. So here's this function that we're debugging called cloud view, and line 290 is where we've dropped off, and that's where we stuck our PDB set trace. And we can see that indeed 290 is where total counts is there. So basically what this thing is showing you is where you are. There are other options to this L command that list where you are in your program. You can sort of pass additional arguments, but this gets you a long way. You can read the rest somewhere else. There's also a command named W, which means where. And who here thinks they have competently read a Python traceback? Yep. Okay. That's very, can you raise your hands again? Okay, thank you. Okay, so W, when you push W, you'll see the frame stack like it would be represented in a traceback. This is where you are in the execution of this program. So I'm gonna page up here real quick so I can see. So that's where I started this thing, the W at the top of the screen there. You can see that we're winding our way down through very low-level things like a server and a web framework and other stuff, and finally winding up at this place where this is our code. So you can see what called each step of the way to where you are, which is awful useful information most of the time. So those are the two main things about getting your bearings about where you are in the code. L and W are useful. So we talked about both of those things. I'm going to talk about showing things now. Once you are at a place in your code, what you often want to do is say, okay, what is the value of this variable? Now that I'm here, how did I get here, and what is the value of the variable? So if we walk back over to our screen here, we can type L again. Oops. We can continue and hit the URL again. Now that we're in this function, let's say that I want to know, this example happens to use the Pyramid web framework. So I happen to know that there's an attribute of the request named path info. Okay, so I can examine the state of my running program at this point just by using this p command. I can also do request post keys. Let's see. Let's request dot. Let's see. Environment. Okay. This is the WSGI environment that my program is running in. You can see that it's awful hard to read when I print it. If I use pp, which is pretty print, I can see it in a slightly better format. So if you're having trouble reading things when you're examining stuff, just use pp. It's very simple. So the other thing about printing values sort of printing things about where you are in the call stack is this other command named A, is args. If you're in the middle of a PDB thing, you can, oops. I'll list this again. I won't list this again. Now that we're here, we have this request object sitting here. We can type args, and the value of args is a request object, which prints on multiple lines here. But it says up at the top of this thing, it says request equal, and then the wrapper of this request, which is it's not all that easy to see. It's probably easier to see in this example where in our buggy.py thing, we actually imported PDB, and when we type A, we say divisor equals 0. That's, if there were more than one argument, we'd see the other arguments and all their values. So now that we've seen how to print things, the way we step through code as we do this are these commands named step, next, continue, until, return. These are all about moving up and down the lines in your program. So when you use all of these things, you're influencing what line number you end up on after you type the command. So one of the commands is step. I'm going to sort of step into a function here, I think. I might not be able to. Yes, probably not. Sure. So right now I'm at line 290, which is the total counts equal whatever thing there. If I hit S, I'm going to step to the next line. If I hit S again, I'm actually going to wind up inside of this tag counts function, which is somewhere else in my code. And what step does is it steps into the next function if a function exists. So I can sort of step into code that I haven't written, or that I have written but that's in another module or whatever. And then I can hit N for next, which is like step, except it does not step into functions. It steps over functions. So I don't have to sort of go all the way down the call stack until the very bottom. So I'm going to use this other command that I talked about called return to return from this function that we entered into back to where I was before. So now if I list where I am, I'm back in this cloud view function. So if you understand this, step steps into a function, N steps over a function, return returns from the current function you're in to back to where you are again. There's also a really cool feature, which I didn't know until I wrote this talk, called Until, which you can, often if you're in PDB, you, like right now, I'm in a for loop, and if I wanted to step through this thing with the next command, I'd have to, I happen to know that there are 3 tags in this thing, so when we're doing for tag and tag counts, we're going to have to iterate 3 times. If I really don't care about iterating over all of them, I just want to get to the next line after the for loop, I can go to the last line of this for loop, and I can type until. Well, before I do that, I'll just hit N to show you what happens when I don't do until. So I go back up to the top of the for loop at this point. That's kind of, if you have 1,000 items, I mean, it's pointless to hit next 1,000 times. So if I'm at the very, there we go. If I'm at the very last line of an indented portion of a for loop, I can type until, hit enter, and it just does all the rest of that stuff and winds me up back at the place at the very next line after the for loop, which is really cool. We've seen what return does. That just sort of returns us back from a function. The other way to navigate code is not by line. We don't necessarily want to navigate through the program by line. We want to sort of navigate up the frame stack and maybe down the frame stack. And the frame stack, all the frame stack is every function that's executed by Python sets up a frame. And inside of that frame are variables. So we can sort of walk up all the way to the point where the server accepted this request and is about to process it as if it hadn't happened yet. So I'm going to show you that in the interactive thing here. We are in our cloud view function again, line 294, and we are down in this views.py module. So I'm going to hit U to step up a frame. And I'm still in the views.py module, but now I'm in a different view. I'm in a different place. I'm at line 42. And if you can see, line 42, it tries to make a dictionary that calls the cloud view thing. So this is the caller of the thing that we were just in. Okay? And if I hit up again, I can see that now we are in the web framework. We are in Pyramid right now, and it's calling the view function, the actual function that we've defined as the thing that should be called when this is hit. And if I could keep hitting up, all the way up to the very, very tippy top of this thing till I get to the oldest frame. And this is the web server that actually issued the request. And we can see what it's doing and why it's trying to do it. And this is often useful if you're just trying to figure out, how did I get here? What is the cause of this misery? So I'm going to walk, the inverse is walking down the frame stack. So D does that, and it brings us to the called thing instead of the caller. So I'm going to remember that hitting enter here repeats the last command. So if I keep hitting enter, I will wind up down at the newest frame eventually, which is where we came from. And that's the newest frame, and we are back inside of our function that we wrote. So those two ways of navigating through lines of code and through the frame stack are super useful. Use them all the time. These are the sort of mainstays of how to debug things. While I'm in a function, I can actually modify the variables that are around. So let's say that I know that there's a bug in this thing if let's say that, for example, what can I modify here? Let's say that I just want to say, so I'm going to skip to the next line, and we are at this point we are about to return. We have not returned yet from this function. We are about to return. But cloud, if I print cloud, I can see that it is a list of tuples. But let's say that, I want to test what happens when this list of tuples is actually empty, because that's when the bug occurs, and I don't want to go through the hassle of recreating a scenario where that might be true. So I could say cloud equal empty list. And now if I print cloud, it will, oh hell. What is it? I think I did. Oh, maybe I can't put spaces in there? Is that what it is? Okay, well. I don't use that feature very much. Didn't work anyway. At this point, you can all leave, because this is all you need to know how to use PDB. All those commands are the main commands you're going to use. Everything else I'm going to talk about is candy on top of everything. Those are the things you need to know. The rest of the things are not critical. Oops. We can talk about breakpoints a little bit. Instead of sort of manually injecting a set trace command, 4 minutes. Okay. Does that mean 4 minutes? That's like really 4 minutes. Okay. So breakpoints are a way to stop execution without actually changing your code. You can use these break commands to inject a breakpoint, and it will stop as if you had changed your code and inserted a PDB set trace in there. But you issue a command to say put a breakpoint at this line number in this file, as long as you're sitting at a PDB prompt, and the next time that line number is executed, it'll drop you back to a PDB prompt. Excuse me. So you can enter PDB and then think, I don't really want to be here. I want to be later in this program. So I'm just going to say, the next time I wind up over this function over here, I want it to break. Do that, hit continue, and then when that function comes up, it'll break. Variations on break, fascinating. And then to disable a breakpoint, you can use a disable command to disable that particular breakpoint. Enable a disabled breakpoint, clear a breakpoint entirely. You can use a T-break, which is exactly like break, but the first time it's entered, it gets cleared, so you don't have to enable it and disable it by hand. And another variation on it, ignores breakpoints. All these things aren't all that interesting. The very advanced things are the commands command, the jump command, the run command, and the debug command, and you can look at those in Doug's tutorial, Doug's fantastic tutorial. Excuse me. You can also define aliases in a file. I'm going to skip through some of this because I want to show you one thing which I think is kind of neat. I'm going to show you IPDB, which is an alternative to PDB. PDB ships with the Python standard library. This IPDB is available from PyPy. So let's imagine that instead of saying instead of saying PDB set trace, I used IPDB set trace. As soon as I do the same thing that I did before, which is invoke this URL, I am dropped at a slightly different place. And this IPDB prompt has colorization and all sorts of gewgaws that make life a little bit easier for you, so you should check this out. There are other things like PDB++, which does the same thing. There are in-browser debuggers. The one other thing I wanted to show you is something called PDB track, which if you use Emacs, if you start a Python program with a set trace inside of it, and hit a URL that is going to invoke this thing. You will wind up in this thing called PDB track mode, which, as you walk through a program, will walk you through the file and will open up new buffers for other files. So that's an interesting thing. I'm going to stop now because I'd like just a few seconds for questions if I can get them. So, thank you.
We've got time for maybe 1 or 2 quick questions. If you'd please come to the microphone so that we can get this on the recording.
Hi. Is it possible to attach to a running process?
It is not. Not with PDB.
As you move up and down the stack, like that's your execution point. So you can then explore. You've moved up 4 steps in the stack, and you can get cool.
Yeah, in the context of that
So your context moves as you do.
You can't change history. You can't sort of change it and then move back down again. But you can go up and down. Yep.
Okay. Thanks.
Yep. Thank you.